All right, let's solve a little bit of a more advanced stoichiometry problem. This problem is asking me how much unused excess is left over. If it's asking me how much unused excess is left over, I first, of course, have to solve to find out who is in excess and, of course, subsequently, who is the limiter. I'm going to use my stoichiometry problem. Because I have two givens, it means I'm going to need to have two templates to set it up. This is the procedure to follow, which of course is on the belly of your mole. It's the number given in the problem, and I have two different problems here. I have 6 liters of KCl, and I've also been given 12.5 liters of the oxygen gas. So since I have two questions, I will have two setups. Both of these are asking me to need liters as my given amount. So that means I'm going to have to convert that. The conversion factor from the box for liters is 22.4. So both of these will need to be divided by 22.4 in order to convert the liters. The next part of the problem is the coefficient of what I am trying to find in the equation. In the original equation there, it told me find grams of KClO3. So the find is the KClO3, and the coefficient from the balanced equation for the find is a 2. I'm also trying to find that for the second equation, so that will also be 2. The coefficient for the given, now that's based on each separate problem. So the given in this problem is KCl, so the coefficient on the given is 2 in this problem. This is the coefficient of oxygen, so the coefficient on that problem is the 3. Now, both of these problems are asking me to solve for find grams of KClO3. If they're asking me to solve for grams, that means I'm going to need to look up the molar mass of those pieces of the problem. That means I need the molar mass of a K, which is 39. The molar mass of K is 39. I'll do it on a separate piece of paper here. So the molar mass of K is 39 grams. Then I have a Cl. Cl is the one guy on the periodic table that we use the 35.5 for. Sorry, it's having a difficult time focusing there. 35.5, so 35.5 grams. And then I have O, and I have it 3 times. So the O is 16 grams. And I have that 3 times. When I add that all up, 39, 35.5, and 16 times 3, I get 122.5. 122.5. And as you well know in the template, the factor is a 1. Now I use my calculator. I could simplify this problem. Of course, I don't need these. 2 over 2 would be gone. So I would simply, in my calculator, put 6 times 122.5, and that is then divided by 22.4. That gives me 32.8, and that was in grams of KClO3. And for my second problem, there's not really much I can simplify, so I have to multiply the 12.5 times the 2 times the 122.5. I hit equals and divided by. Because I have two things down here on the bottom, they're going to go in parentheses when I put them in my calculator. When I do that calculation, I end up with 45.5. So I end up with 45.5. It looks like 45.5. 7, and that's in grams of KClO3. So at this point, I can tell who is my limiter and who is my excess. My limiter is the KCl, because that is associated with the smaller number, and my excess is my O2. I have too much O2. So the first part of the problem is determining who is your limiter and who is your excess. The next part of the problem requires me to set up another stoichiometry problem. So once I first determined who's my limiter, it's KCl, and who's my excess, I can figure out how much unused excess is left over. To do that, I have to set up another stoichiometry problem that uses the same template, but now I have to write the find and the given. So the question is how much unused excess. So what am I trying to find? I'm trying to find excess, which means what have I been given? That would have to be my limiter. So I have to refer to my problem, who is my excess, that's the O2, and on the back side of the paper, who is my limiter is the KCl. Whenever you're solving a stoich problem, you have to be given amount for the limiter. So I have to go back and see how much KCl did they give me. And if you look back in the original problem, you can see they gave you 6 liters of it. So I'm solving this problem that I set up right here. I have been given 6 liters of KCl. If they give me liters, I have to do 22.4 to convert that. The coefficient of what am I trying to find? Now it's O2. So the coefficient on that is a 3. Over the coefficient of what I was given. The given is my KCl, so that coefficient is a 2. I have to solve this problem in the same units that they gave me the excess in. So, because I'm going to have to subtract to find out how much unused I had. So, that means I'm going to have to solve it for liters. If I solve it for liters, this number becomes 22.4. And that, of course, in the template is a 1. When I solve this problem of 6 times, well, technically I'm not going to divide or multiply by the 22.4. One's on the top, one's on the bottom. So now I'm at 6 times 3 divided by 2. That, of course, gives me 9 liters. What this is telling you is that you only needed 9 out of the 12.5 liters. So how much unused is left over? That's the problem. 12.5 subtracting, and that's 12.5 liters of O2, take away the 9 liters of O2, which means I had 3.5 liters too much. That's the answer to the question, how much unused excess is left over? 3.5 liters too much. There's a way to check this problem. To check this problem, all you have to do is put the 9 liters back into your original equations. If we go back and look at our original equations, in this spot right here, I had 12 liters, 12.5 liters. It was too much. It gave me a yield of more than the KCl did. If I simply substitute in the 9 liters into the equation, you will see that both problems work out to be 32.8 grams of KCl being produced. That would let you know that you solved the problem correctly with the 9 liters.